All right, good afternoon and welcome to Master Talker online class. In today's video, we'll be solving questions on um, theorems of quadratic equation. Now, the first question said, that is question number 60. Okay, it said the value or values, the value of k, okay, for which the quadratic equation, for which the quadratic equation x squared minus kx plus 4 equal to 0 has equal roots, is or are dash. Okay, now when a quadratic equation has equal roots, it means that b squared, okay, for a quadratic equation to have equal root, it means that b squared minus 4ac will be equal to 0. That is what to make them to have equal roots. And from this place, we can see that our a is equal to 1, the coefficient here, and our b is equal to minus k, then our c is equal to 4. So if you put it here, you're going to have minus k all squared minus 4 into 1, then into 4 is equal to 0. So this is k squared minus 16 is equal to 0. So I have that k squared is equal to 16. So k will now be the square root of 16. Don't forget your plus or minus. So k is equal to what? Plus or minus 4. Okay, that means that k is equal to 4 or minus 4. Right? So that is that for that. We move to the next question. Question number 61. Question number 61. For question number 61, we have question number 61 said if alpha and beta, are the roots of x squared plus 4x minus 1 is equal to 0, then we should find alpha minus beta all squared. Okay, this is a very simple question. Solution: the first thing we need to find is alpha plus beta. And what's the formula? Minus b over a, which is what? Minus, this is my a, b, and c. So minus 4 over 1, which is what? Minus 4. The next thing is alpha beta. Alpha beta is c over a, which is what? Minus 1 over 1, which is minus 1. Because my a is equal to this 1, my b is equal to this 4, and my c is equal to minus 1. So after that, you need to know this formula, that alpha minus beta all squared is equal to what? Alpha plus beta all squared minus 4 alpha beta. Okay, so if you now put it, you're going to have minus 4 all squared minus 4 into minus 1, which is what? 16 plus 4, which is what? 20. All right, very, very simple. So the next one, question number 62. Question number 62 said that if alpha and beta, question number 62 said if alpha and beta are the roots of x squared minus 3x plus 1 equal to 0, then we should find just alpha minus beta. The same process, the same procedure. Solution: the first thing you need to find is what? Alpha plus beta, which is what? Minus b over a, which is a minus into minus 3, then over 1, which is what? 3. Because my a is 1, my b is minus 3, and my c is 1. So alpha beta is equal to c over a, which is 1 over 1, which is 1. Okay, then alpha minus beta all squared, I want to show you something, is equal to what? Alpha plus beta all squared minus 4 alpha beta, right? Then to find only alpha minus beta simply means the square root of these people. The square root of alpha plus beta all squared minus 4 alpha beta. So what do I have? The square root of, I've gotten this one to be 3. So 3 squared minus 4 into 1. So what do we have? The square root of 9 minus 4, which is what? The square root of 5. So root 5 is the solution to that. Then question number 43. Question number 43 said if alpha and beta are the roots of x squared. Number 43 said if alpha and beta are the roots of x squared minus 5x plus 10, okay, equal to 0. So the next say we should find alpha squared plus beta squared. All right, it's very, very simple. Solution, the same method. The first thing you need to find is alpha plus beta, which is what? Minus b over a. Minus b over a. Don't forget that your a is equal to this. There's nothing here, so 1. Your b is equal to what? Minus 5, and your c is equal to 10. So what does it mean? So minus b over a is now minus into minus 5 over 1, which is what? 5. Then your alpha beta is equal to c over a, which is what? 10 over 1, which is 10. So my alpha squared plus beta squared, the formula is what? Alpha plus beta all squared minus 2 alpha beta. So what do we have? 5 all squared minus 2 into 10. So what do we have? 25 minus 20, which will give you what? 5. All right? Very simple. We move to question number 64. Question number 64 said, if 4 plus m x squared plus m plus 1 x plus 1 is equal to 0 has equal roots, then we need to find m. Then we should find m. Okay, now there's something I told you about equal roots. Solution, I said for a quadratic equation to have equal roots, therefore b squared minus 4ac must be equal to 0. And you see that your a is equal to 4 plus m, and your b is equal to what? M plus 1. Then your c is equal to 1. So if we put it here, we're going to have m plus 1 all squared minus 4 into my a is 4 plus m, then into 1 is equal to 0. So what do we have? Opening this bracket, I have squared the first one, m squared, multiply the first one and the second one, double it, you have 2m, square the last one, I have what? Plus 1. Then opening here, 4 times 1 is 4. So that's 4 times this, I have minus 16, sorry. Minus 16, then minus 4m is equal to 0. So what do we have? This is equal to m squared, this and this will give you minus 2m. Then this and this is going to give you 15. Minus 15 is equal to 0. So this is m squared minus 3 and 5 minus 5m plus 3m, then minus 15 is equal to 0. So I have m into m minus 5. The same thing here, m minus 5 is equal to 0. I have plus 3 here. So I'm having m minus 5 into m plus 3 is equal to 0. So I'm having that m minus 5 is equal to 0, or m plus 3 is equal to 0. So which shows that my m is equal to 5, or my m is equal to what? Minus 3. So that is that for that. We move. So question number 65. Question number 65. Now, question number 65 said, obtain a quadratic equation. Obtain a quadratic equation. Obtain a quadratic equation such that the sum of the roots is 10 and the product of the roots is 4. Okay, solution, this is very simple. Solution, we tell them that what? To obtain any quadratic equation, we should know this formula that say that what? S squared minus sum of roots, you put x, then plus what? Product of that roots is equal to 0. So let us put it. So s squared minus, they told us that the sum is 10. So 10x plus the product is 4. 4 is equal to 0. So this is the quadratic equation. Very, very simple. Okay. So the next thing we need to do, question number 66. So question number 66 said, given that 66 said, given that one of the roots of given that one of the roots of the equation 9x squared plus qx plus 3 equal to 0 is the square of the reciprocal of the order. Okay, they now say comma find the roots. Okay, we have to find the roots. All right, solution. Okay, they say that one of the roots of this, so we have that alpha. Do I use alpha and beta to get this? They say find the roots. We need to find those roots. First of all, we need to find q. Okay, we know that let's say let alpha and beta be the roots. So they say that alpha is equal to the square of the reciprocal, so 1 over beta squared. Okay, so that's what they told us. So which means alpha beta squared is equal to 1. Okay, that's what they told us. Okay, even without that self, even without that, okay, even without this is what they gave us, that one of the root is the inverse of the square of the other one. But I know that according to alpha beta is equal to what? C over a, which is equal to what? 3 over 9, which is equal to 1 over 3. Okay, I've gotten that alpha beta. So instead of me writing alpha now, I can put it as 1 over this. So I will now write instead of writing alpha, I'll say 1 over beta squared, okay, in bracket of another beta is equal to 1 over 3. Okay, this can cancel one of these to have that 1 over beta is equal to 1 over 3. So therefore my beta is equal to 3. So if beta is equal to 3, so how do you get alpha? We have that alpha is equal to 1 over beta squared. So my alpha is equal to what? 1 over 3 squared. So my alpha is equal to 1 over 9. So therefore the roots are 3 and 1 over 9. So these are the roots. 3 and 1 over 9 are the roots. Okay, they say we should find the roots. So the next question number 67. Question number 67 said, given that one of the roots of this equation is the square. Okay, there is a mistake. This is repetition of question, but not complete. So let's talk about question number 68. Question number 68. Question number 68 said the value or values of k for which the value or values of k for which the quadratic equation x squared minus kx plus 9 equal to 0 has equal roots is or are. Okay, so solution. So what do we do? I told you that for a quadratic equation to have equal roots, so what do we do? For any quadratic equation to have equal roots, so okay, sorry, they say for what value of this is this what has real equal roots? Okay, so for them to have has real equal roots. Okay, for a quadratic equation to have equal roots, I thought that b squared minus 4ac will be equal to 0. So from here I have that my a is 1, while my b is equal to minus k, and my c is equal to 9. So if you put it here, I have that minus k all squared minus 4 into 1 then into 9 is equal to 0. So my k squared minus 36 is equal to 0. So my k squared will be equal to 36. then my k will now be equal to what? Square root of 36 plus or minus. So my k is equal to plus or minus what? 6. Okay, plus or minus 6. So in the option we have right. So this is not inequality. If it's inequality, there's a mistake there. Let's maybe this is inequality. Okay. So question number 69. Question number 69. Question number 69 said that if alpha and beta, if alpha and beta 69, if alpha and are the roots of 2x squared, 2x squared plus 4x minus 6 equal to 0. Then alpha plus beta all squared is what? I think that's a typo error. There's a typographical error there. So, but solution, if you have that alpha plus beta all squared, simply means minus b over a all squared, which is what? Minus 4 over 2 all squared, which is equal to what? Minus 2 squared, which is equal to what? 4. And 4 is the correct option. So let's move to the next one. Question number 70. Question number 70 said if alpha and beta are the roots of ax squared plus bx plus c equal to 0, then I say find the value of 1 minus alpha squared into 1 minus beta squared. Okay, solution. So the first thing we need to do is to evaluate this thing. So I have 1 minus alpha squared and 1 minus beta squared. So let's open the bracket. 1 times this I have 1. 1 times this I have minus beta squared. Minus this time this I have minus alpha squared. Minus times minus plus. This time this will give you beta squared alpha squared. So if you arrange it very well, I'm going to have 1 in bracket. Sorry, 1. If I factorize this place, they have minus in common. So I have beta squared plus alpha squared, then plus alpha and beta with all squared. So if you arrange this side very well, I'm going to have 1 minus alpha squared plus beta squared, okay, then plus alpha plus beta all squared. Sorry, alpha beta all squared, alpha beta all squared. Okay, so now I know the meaning of this man. So this is 1 minus, this one means alpha plus beta all squared minus 2 alpha beta. Okay, that's the meaning of this one. Then plus alpha beta all squared. So if we do that, we're going to have, let us put everybody, we can now substitute. If we substitute, we have that so this is equal to 1 minus, now alpha plus beta is minus b over a. So I have minus b over a all squared minus 2 into c over a. Okay, you close. Then plus what? C over a all squared. Okay, so what do we have now? 1 minus into b squared over a squared minus 2c over a, okay, plus c squared over a squared. So if you open, I have 1 minus b squared over a squared plus 2c over a, then plus c squared over a squared. So if you now collect like terms, LCM of this is a squared divided by 1 times this, I have a squared here. This divided by this 1 times this, I have b squared here. This divided by this a times this, I have what? 2ac. This divided by this 1 times I have what? C squared. So this is the solution. So a squared, or let me write it very well. I'm going to have a squared minus b squared plus c squared, then plus 2ac, everybody over what? A squared. So that is that for that. Then question number 71. Question number 71. For question number 71, I have question number 71 said that if alpha and beta, if alpha and beta are the roots of, if alpha and beta are the roots of the equation, please check, is that, hello, is it going? Okay. If alpha and beta are the roots of the equation x squared minus 4x plus 1 equal to 0, then I say we should find alpha cube plus beta cube. Then find alpha cube plus beta cube. Okay, solution. This is very, very simple. So we tell them that alpha cube plus beta cube is equal to what? Alpha plus beta all cube minus 3 alpha beta in bracket of alpha plus beta. Okay, so this is equal to, don't forget that alpha plus beta is minus b over a, so which is give you 4 over 1, which is 4. Okay, don't forget that. In fact, the first thing we are supposed to find is our alpha plus beta, which is minus b over a, which is minus into minus 4 over 1, which is just 4. And our alpha beta, which is what? C over a, which is 1 over 1, which is 1. So if you put it, this is cube minus 3 into 1, then into 4. So which is what? 4 cube, I think, is 64, right? 4 cube 64, yes, 64 minus 12, which will give you what? 52. So that is that. Question number 62, 72. We are progressing. Question number 72. Question number 72 said that if alpha and beta are the roots of, if alpha and beta are the roots of x squared minus 3x plus 1 equal to 0, then I say we should find alpha squared minus beta squared. Okay, so don't forget that solution. The first thing we need to get is alpha plus beta, which is what? Minus b over a, which is minus into minus 3 over 1, which is 3. Then alpha beta, which is 1 over 1, that is c over a, which is 1 over 1, which is 1. Then before we now talk about getting alpha squared minus beta squared, this is difference of 2 squared. So this is alpha plus beta and alpha minus beta. And I've told you the meaning of this before. So this is what? Alpha plus beta, then the square root of alpha plus beta all squared minus 4 alpha beta. So let us now put everybody. This is 3, the square root of 3 squared minus 4 into 1. So what do we have? 3, the square root of 9 minus 4, which is what? 3 root what? 5. 3 root 5 is the correct option. So question number 73. Question number 73. Question number 73 said, find the value, find the quadratic equation whose roots are whose roots are q plus 1 over 2 and 2p minus 1 with p plus q equal to 1. Okay, solution. Now for you to find any quadratic equation, you need the sum and the product. So the first thing we need is the sum. The sum means to add the two of them. So how do we add? We have that q plus 1 over 2 plus 2p minus 1. So which will give you Okay, which will give you P okay. So but they say that P is plus Q is equal to 1. So which means that P is equal to 1 minus Q. So I have Q plus 1 over 2 plus 2 into 1 minus Q. Okay, minus 1. So what do I have now? Q plus 1 over 2 plus 2 minus 2Q, then minus 1. So what do I have now? I'm going to have that this and this will give you minus Q. So this is okay. So if I say that this is Q plus 1 over 2 plus P plus P, P plus P will give me 2P minus 1. So these two can give me P plus Q, then plus another P, then minus half. Because 1 half minus 1 will give you minus half. So but these two they say is equal to 1. So I have that 1 plus P, then minus half will give you what? Half plus P. Okay, half plus P is the sum. So let us get the product. To get the product, the product is equal to what? To multiply both of them, that is Q plus 1 over 2 and 2P minus 1. So this time this will give you 2PQ. This time this will give you minus Q. This time this will give you plus P. Okay, why this time this will give you minus half. So what do we have now? So we are going to have that the product is equal to I want to factorize. Is there any way to factorize? Okay. Okay. So let me make everybody to be in terms of P. So therefore, my Q is equal to 1 minus P. So if I put it here, I'm going to have 2P in bracket of 1 minus P. Okay. Then minus another 1 minus P. Okay. Then plus P minus half. Okay. So I'm going to have 2P. This time this 2P. This time this 2P squared minus 1 plus P. Okay. Then plus another P minus half. Okay. So I'm going to have a 2P, 3P, 4P. So I'm going to have 4P, 4P minus, okay, let me just say minus 2P squared, okay, plus 4P, then minus 3 over 2. But this and this will give you minus 3 over 2. So this is their product. So to get the quadratic equation, I think there's a typo error here. There's a typographical error here. I think there is a typographical error here. So, but if not, so what do? We now say that for a quadratic equation, we have the quadratic equation is x squared minus the sum. You put what? X there plus the product is equal to 0. So what do we have? X squared minus the sum here. We got the sum to be 1 over 2 plus P. Put our x, then plus the product will now be minus 2P squared plus 4P minus 3 over 2 is equal to 0. So this is the quadratic equation. Okay, this is the quadratic equation. So let's go to question number 74. Question number 74. For question number 74, I'm going to have okay, there's no 74, rather we have 76. For question number 76, they say find the value of r for which the quadratic equation p squared plus rp plus r equal to 0 has no real roots. Okay. Now, if a quadratic equation has no real roots, then it means it has a complex root. So for it to have a complex root, it means that b squared minus 4ac, okay, will be less than 0. With less than 0 means that there will be minus inside that place, which will make it a complex. It does not have a real root. So what is my what do I have now? So from here, my a is equal to 1, my b is equal to r, and my c is equal to r again. So if you now put it here, you are going to have r squared minus 4 into 1, then into r is less than 0. So what do we have now? R squared minus 4r is less than 0. So what do you have? R into r minus 4 is less than 0. So what are we having? What do we have? That r is less than 0, or r minus 4 is less than 0. So r is less than 0, or r is less than 4. Okay, so what do we have now? R being less than 0 and equally less than 4. So that is from negative infinity to 4. From negative infinity to 4. Let's check if it's there. From negative infinity to 4. Or we can equally say open set of 0 and 4. We can use open set of 0 and 4. Okay, we can use open set of 0 and 4. Okay, so that is that. So the next one, so the last but not the least, the 79. There's no 77, 78. So 79. For the 79, they said the root of the equation this will be real and identical if the root of the root of the equation x squared plus px plus q equal to 0 will have, okay, will be real, would be real and identical. That is equal root if what happened? Okay, if b squared minus 4ac is equal to 0. So that is what to make them identical, the same. So I know that my b is p, my b is equal to p, and my c is equal to q, my a is equal to 1. So I have what? P squared minus 4 into 1 then into q is equal to 0. So what do we have? That p squared is minus 4p, so minus 4q is equal to 0. So what do we have? So what is in the option? So in the option we have okay, this one moving here, I have that p squared is equal to what? 4q. Okay, so we now have that p is now what? The square root plus or minus of 4q. So my p is equal to what? Plus or minus 2 root what? Q. 2 root q. So thank you very much for watching. In our next video we'll talk about polynomials. Bye bye. Please like, share and subscribe.